Hey badass coders, soon to be coders, and engineer extraordinaires. In today's video tutorial, we are going to continue moving forward on our Python calculator, and we are going to use the single responsibility principle, and we will take the calculator logic and move it to its own dedicated class, and we will review a little bit on using classes. Let's start by reviewing a class in Python. In the last video, we looked at classes for the first time. So just for a little review, we use the class keyword followed by a custom name for our class. And that's always capitalized or camel cased, where the first letter of each word is uppercase, followed by a colon. All the class attributes, which are the variables and the methods, that's just a general term for each attributes. All the class attributes are tabbed in, as you can see, so that they remain within the scope of the class. This is the declaration point. So this is the declaration. This is our blueprint. We're saying what this class is going to do. So we typically name our data here in our variables, and then we name our methods, or what we're going to do with that data. Down here outside of the class is where we are calling our class attribute, so the class variables or the class methods. So you could call this the call point. So this is the point of use, and just remember that we could have this class declared in any specific file, and then when we call our class, it does not have to be right down here right after our class declaration. This could be in many files in many different classes and other methods where we are calling this specific class. So just know that it's very versatile in where we can call this. We covered the fundamentals of classes in the last tutorial. So if you want to check that out, go ahead and check out the video right before this, and they are all numbered. I want to dig a little bit deeper into classes and what makes them so powerful, which is inheritance. We can start by creating a class to be our superclass using the class keyword. Let's call this four-leg animal. Use our colon, and inside the body of our class, create a class variable with the value of 4, and I'll create a comment here. This is our class variable. Let's create a class method using our typical function keyword here. Call this walk, and as best practice goes, we use the self keyword and add a comment, call this our class method. And inside of our class method, we could add a print statement. The print statement will state the animal walks on 4 legs. At this point, we don't have a superclass necessarily. Superclass is a reference to the relationship between classes. So if I was to come to our dog class here and trailing the name of the dog class, I'm going to add parenthesis and the name of four-legged animal. Now, four-legged animal has become the superclass to the dog class, meaning this dog class has access to the class attributes, so the class variable and the class method. Now let me show you what I mean. I don't have to redeclare or call legs or walk within the class declaration of dog here. I can actually access that at the call point after we create an object instance of the dog class. So here's dog. We created these objects, we initialized them, we gave them values. Now I can go into dog1, and with .syntax, you can see I have access to legs now with code completion. Because it's a variable, I'm just going to put it in a print statement so that we can see an output, since we're not actually doing anything with it at this point. But I just want you to see that we have the value of 4 here in our output. So you can probably already see just how powerful the concept of inheritance is. And below this, we could also print out dog1 dot walk. And then remember, if we're calling a class method, we want to call it with the open closed parenthesis. I'm going to actually get rid of the print statement here just so you can see it, because we are actually only printing something right here in the walk method already. So that's going to appear in the output. So let's go ahead and run this one more time, and you can see legs value 4, and walk method is printing the animal walks on 4 legs. So that is the power of inheritance. So that is the power of inheritance between classes. And one more thing before we get started with refactoring our calculator code, I also want to look at the topic of class attributes one more time and distinguish the difference between a class variable versus an instance, a class instance. This dog class demonstrates the difference between instance attributes and class attributes. So the dog class has 2 class attributes. We have breed, this is a class attribute. And remember that phrase, class attribute, that is a general term for variables or methods within the class. So we have 2 class attributes, our breed, which is also a class variable specifically. And even though our class method here, we can refer to it as a class attribute in a general term. And this class attribute, which is also a class method, is specifically an instance method. Now, why is that? This is a special method in Python, also known as a constructor, and it's used to initialize an object when it's created. And how do we know that? We know that because of the name of the method, which is the underscore init here. So this method is automatically called when we create an instance of a class. So down here is where we've created our instances. And this is the call point or the use point, and it takes the instance object as its first argument, which is by convention named self. And this is the instance object right here. So in this case, the init method takes 2 arguments specifically, which we have name and age here, and it sets them as instance variables of the object. And how do we know that? Because it automatically sets it up to where it allows us to enter a name and enter a number here for the age. So these can be accessed using self.name and self.age, which is what we do up here inside of our initializer. Okay. So this is saying that we are passing a value into this method, which is right down here at the instance. And then we actually set them inside here. And all you have to remember is this is the syntax for creating instance methods. So instance variables are actually speaking ahead of time. They're saying, hey, when you create an object to be used, here's what we want you to do. And those values only relate to that specific object. So this first object we named dog1. The second object we named dog2, and you can see that they have different values. So Harold and the number 3 are specific to dog1, and Duke and the number 5 are specific to dog2, and we can see that down here as we print each statement. Harold and 3 are related to dog1, Duke and 5 are related to dog2. So you can see that dog1 for the name and age doesn't have access to the values of Duke and 5. Equally, for dog2, you can see that for name and age, it does not have access to Harold and 3. They are their own copies of the dog class. So just remember, this is how you would set up instance variables. And up here is how you would set up a class variable, making this shared among all the instances of a class. And we can see that down here for dog1 when we tap into the breed variable. The class variable has the unknown value, and then even for dog2, which is a totally separate instance, we also have access to that unknown value that was described up here in the class declaration. So just remember, class variables are declared like so, and instance variables are declared with the self keyword prefix to the variables. We are back in our calculator Python code, and in the last video we refactored using the single responsibility principle, and we took all the memory related logic and moved it into our result memory class here, and then called the result memory class and its class methods in the appropriate areas of our code where we were using it prior. So it can be a little hairy, aggravating, frustrating, all the above to refactor code. So there is a best practice approach to minimize risk of introducing bugs and breaking existing functionality. And that approach is to first identify that core functionality that the class will have, and then we extract that into separate methods based on whatever is being done. So by doing this, we ensure that that functionality remains intact throughout the refactor process. You don't want to just start pulling pieces out, because then we are just going to have spaghetti of code everywhere and things are going every which direction. So it makes it easier to test and debug the code, as well as easier to maintain in the future. And then also, once that core functionality has been separated, you can focus on organizing the code and making it more readable and maintainable, and then refactoring further. So for starters, what we will do is, we already know that we want to create a class for our calculator. So we can use the class keyword, call this calculator, and end that with a colon to create our class. And there we go, we're done. And then down here, we can actually come to the call point. And this is where calculator was originally being called. And so we're going to have to do a few things to make sure this continues to work. So it's going to look totally different. But ultimately, what we can do here is replace this calculator, and we can actually refer to it as calculator again for our variable name. And then we can call our calculator class and make sure to use those initializers, the constructor here. And now we have our class declared for the calculator, and we are creating a new object, a new instance of it right here. And before we pass anything in or do anything else, this was a great, huge first step in structuring our refactor process. We can start by going up to our input for the user, our input method here, and we can take this getInput method from the global scope and then place it inside of our calculator class. So let's go ahead and grab this entire method, and I'm going to use Command X here to place inside of our calculator. And then you want to make sure all this is tabbed in so that it's within the scope of the calculator. You can highlight and hit tab, and that will tab it all in. So now this method is within scope of our calculator. I'm going to scroll down and grab our calculate method, highlight this, and I'm going to paste this into our calculator class. highlight and hit tab to make sure that's within the scope of our calculator class as well. And we have the print result method, which was only printing the result that we got back from the calculation. At this point, we don't really need this anymore because of the way that we are going to refactor this. And this is where it becomes sort of an art and science to refactoring. You want to look at what exists, and you need to look at what you want it to be or what you want it to become. Since we want to maintain the same functionality, the only art and science behind it is kind of renaming, right? So this was printing a result, and then we have the calculator method, which was running the actual calculation. And so we could rename some of this. So we could actually remove print result, but just in case we need it, and to be sure, we can actually just comment it out for now. And then when we get down to the calculate method, we can take this and actually copy this and paste it into our calculator as well. And then once again, highlight all this and tab in to make sure that we are in scope of our calculator class. During a refactor, you want to consider what each method or function is doing and what it's calling, right? So before, we had a calculator function here that was basically the shot caller for the entire app. This was called and it ran the entire app. So this is a crucial point in the code because it has to do with running the app. And what we did is we took that shot caller authority and we gave it now to this other object instance. So that means we have to make some trade-offs here and actually start here from that entry point. And I'm referring to the entry point as being where the data begins or where the app begins, right? So there's a beginning in time where the app runs from, and it's at that call point that we used to have for the calculator method here, or the calculator function, which is where the app used to start or fire up from. So in here, what we want to do is we want to pass something into this. And so we want to pass that result memory into this so that the calculator now has that information, because we took all of our logic that was once global and accessible by everything, and we put it into a class. So now it's sort of hidden. It's within this class now. So we have to get that result memory that was initially being fed in through here into that calculator class somehow. So we can actually pass this result memory in here. And now this calculator class has access to that result memory. Now it might not jump out and seem so clear when you're working on your own projects. And that's why it's important to think about what each method is doing and what it's calling and what it needs. So we've taken and modified this calculate method to use the result memory attribute instead of the global result memory variable. So we could also change or add a new method to run this entire thing. So whereas we used to call this our calculator before, we could rename this and call it something that is actually more appropriate for what it's going to be doing, which is running the app. Since we have a class that's called calculator now, and it's housing all of the logic for calculating, right? Now we can rename this method to run all that calculation. So since this was the starting point of our app, let's just go through this line by line then. In the body of our run method, we are calling the get input. And you can see that this says that it's not defined, and we've got the little squirrely lines underneath. And what have we learned about classes? When it relates to the instance of the class, when this is created, when an object is created down here, right here, for our calculator class, and we want to deal with that instance of it, we always know that we use the self keyword. So we can add the self keyword and dot here to say that, hey, within this class, this calculator class, I want to access the input method, which is right here. It's also within this class. And the same for calling our calculate method here. We are referring to a class method now. This method right up here is within our calculator class. So when we want to call it within a class, we are going to use that self keyword once again. And then notice down here for result memory. Well, where is result memory? Result memory is a class up here. It's in another class. But then we also notice in our calculator, we are passing result memory in. So here we will actually call result memory as well with the self keyword. And most of the logic in this run method is still there. It's just that we're referring to the other objects in relationship to being in a class now. And so we need to be able to run this specific method here, which actually fires off the entire calculator to run. So how do we do that? We have our calculator object, we have access to the result memory in our calculator, we're passing that in, but now we have this calculator nickname or variable name for our calculator object. And so what we can do is we can call that, and somehow we need to be able to access this run method, which is in our calculator class. So because we've already initialized that calculator class here, we have access to that by using the dot syntax, and we can say run. And because it's a method, we include both parentheses here for the method call. And we can clean this up a little bit here. I'm gonna go ahead and keep that print result here, just because we don't know if we broke anything just yet. And let's go ahead and give this a shot and run it and see what errors we get. And we do have an error here. We can see that the calculator takes no arguments. So let's close this. And let's see what it's referring to. So we have our calculator, and at the call point we are saying that the calculator takes in the result memory here. So what did we learn about classes in general? That we need an initializer or a constructor method within our class to set up all the attributes. So we can use the def keyword underscore init. We can get rid of all this. And then let's just think for a minute logically, what are we passing into this? So we know that we use the self keyword just as a good practice. And then we have a value coming in, and what is that? It's the result memory. And then what do we want to do with that? When we pass that in, we want to say self because it's going to be on the instance that's created of the object. And then we can say result memory. And this is our instance variable. Remember, it relates to the specific instance of the object that's created, which is down here, just in case that's getting confusing. This is our object instance, and we're passing it in there for this instance. And then we are going to bind that with the result memory that's coming in. Now, considering the self keyword, also when we're declaring methods, remember the best practice is to set these up and to keep them in reference to the class here. So we always pass in the self keyword. And the same thing here. And on run as well. Let's go ahead and save this and run. And there we go. We have successfully refactored all of our calculator logic into a calculator class. So we can start by multiplying, adding the multiplication operator and multiply 3 by 2. And it looks like print result is not defined. So good thing we didn't delete that. So it's still looking for print result is not defined. And where is that? Line 61 and line 70 it looks like. So let's close this. We can go back and look at that print result method, which we have right here. And sometimes when we get errors like this, it gets really scary because it seems really confusing and it's like a puzzle. But if you start from the top down and you read top down and left to right, it's usually pretty logical. So we have a method that we were calling print result. Okay, it's calling this method that we define. But let's just ask ourselves, well, what is a method? A method is just a function. It just does something. Okay, so then the first thing we do is we look inside of this and we say, what is it doing? Well, lucky for us, the only thing that this method is doing is just using a simple print statement to print the passed in result. So all we really want to do with this is print it. So we're not passing this around, we're not making any crazy calculations with it or anything. So what we can actually do here is just change all of this to just print the result, that's it. And we'll go ahead and keep this for now, but I'm pretty sure this is going to fix the issue, so let's go ahead and run this. And we have our calculator running. Let's multiply 2 times 2, and we can see that we get a proper calculation for a multiplication operation. 2 times 2 equals 4. We could exit, we could continue just to make sure everything's in working order. And there you go. See, this is why we refactor this way and then run appropriate tests to make sure that our code is functioning correctly. So we have another error when we try to continue, which was to call the calculator again and start over. So it's saying that this object is not callable on calculator. As we found out before, these errors are not too scary and are actually very logical and helpful. If we look at this, it says that it's a type error. That calculator, with an uppercase C at the beginning here, the object is not callable. So let's think logically about when this is happening. The calculator started initially and it worked. It was only at the point that we wanted to continue. Well, we know where that logic is. That's in our while loop. And then also notice that it gives you the line that the issue is occurring and on or near line 78. So let's close the terminal here and go down to line 78, and look what we have here. We have a call to calculator, but do you remember that we created a calculator object class here, and we're passing result memory into that class, and all that logic is in this new object class. And what did we have to do to run this class? We renamed a method from calculator to run, right? So now the way that we actually start our calculator is through calculator.run with the method parenthesis here to call the method. So then it makes sense, if that's how we're starting it, that's probably how we need to restart it. Let's go ahead and run this. All right, nothing's broken so far. We could use subtraction, and we could take a 4 minus 2, we should equal 2. And let's go ahead and hit C to continue and hit enter. And sure enough, it begins again. And then we can add the plus sign and do a 6 plus 2, should get 8, which we have. And let's make sure our exit works. And then it looks like we've exited the Python calculator code here. So in this tutorial, we refreshed on classes, and we looked a little deeper into classes on inheritance and really distinguished the difference between a class variable versus an instance variable. And then we used the class for our calculator to hide all of our logic in there. And we are approaching the single responsibility principle in this first aspect of a refactor. But we are going to use the single responsibility principle even further to separate all the logic out into their own separate classes. But as you could see today, it was a big job to refactor all that logic out into its own calculator class. But you guys did a great job, and this will become more and more familiar to you the more that you do it. So I suggest that you start smaller projects and get used to refactoring your global code lines into functions, and then those functions and code into classes, and get used to the feel of refactoring. So I'll see you guys next time.